everyone. Given the following statements, if the angles are a linear pair, then the angles are supplementary. We're going to write and label and explain why the statement is either true or false for each of the three statements. So we have converse, inverse, and contrapositive. So the the conditional statement is a if, then. If, and then. And that was already given to you. And then, so that's if P, then Q. For the converse, what you do is you switch the Q and P. This is your hypothesis. This is your conclusion. So you're switching your conclusion with your hypotenuse, or your hypothesis. And so you're going to get if Q, then P. And I already took the liberty of typing it out there. So if the angles are supplementary, then the angles are a linear pair. Now the inverse goes with the if-then statement. They both start with the I and inverse. So all you do is you take your P and Q, your hypothesis and conclusion, and you negate it. If the angles are not a linear pair, then they are not supplementary. And then for the last one, contrapositive always goes with the converse. They both start with C's, and you're going to negate the converse. So you're going to say, not if not Q, then not P. So if the angles are not supplementary, then the angles are not a linear pair. And then we also have an example of a biconditional. Two angles are a linear pair if they're adjacent angles whose non-common sides are opposite rays. So let's explain why the biconditional is true. So here's your biconditional. Two angles are a linear pair if and only if they are adjacent angles whose non-common sides are opposite rays. So it's true because you can switch the P's and Q's. So if I say if P, then Q, which is this statement, and that statement is true. And if I write it as if Q, then P, so that would be if two angles are adjacent angles whose non-common sides are opposite rays, then the two angles are a linear pair. So I just switched the P's with the Q's there. So since these are both true, then the biconditional is also true. And I wrote these out. These are your symbolic forms and your biconditional statement. You have the conditional and the converse. So if the conclusion, then the hypotenuse. If both the conditional and its converse are true, then they can be combined into a biconditional statement. So you write the hypothesis if and only if the conclusion, which is what we did. And that's it. Thank you. Have a nice day. Bye-bye.